Hello everyone. In today's video we will discuss about IPC methods. With respect to this one, we are discussing the contents are introduction, pipes, P-open, P-close functions, co-processors, P-force, system version IPCs, message queues, semaphores. First we need to understand what we mean by IPC here. IPC enables one application to control another application and several applications to share the same data without interfering with the one another. So you might be heard the term IPC, that stands for inter-process communication. So that the inter-process here, two or more processes, they are communicating with each other for sharing the data or information. For that purpose, we are using the different communication methods. Usually, this concept we are using in multiprocessing systems. Okay. There are, as I told already, there is a many methods we are using for IPC. The first one is half duplex pipes. Second one P-force. Third one is full duplex pipes. Then named full duplex pipes, message queues, shared memories, semaphores, sockets, streets. The first 7 forms of the IPC are usually restricted to IPC between the processes on the same host. The last 2 are used, that is the sockets and streams, are the only 2 that are generally supported for IPC between processes on different hosts. Here we need to understand the 2 concepts. The first one, same host means there is a 2 or more processes, they are interacting with each other on the same system. And the process 1 is also in the same system, process 2 is also the same system. They are communicating with each other by using one of these methods, first 7 methods. On the other host is nothing but the one process exists in host A, another process exists in host B, say for example. So in this way we can communicate, that is by using client side streams. You might be heard the term client server. Assume that you are the client side connected and the server, I think service provider of the emails like Google, Yahoo, Reddit. Okay. So in that case, what happened? The one process is running on the server side and one process is running on the client side. So this is how we are establishing the connection with these 2 processes, that is by using sockets. So first method we are using for IPC is pipes. They are having the pipes are nothing but the oldest method. They are having some certain limitations. The first one, they have been a half duplex. That is nothing but the data flows in only one direction, that is from source to destination or destination to source. At a time we could not perform the operation like source and destination. Only one side of the data can be flow here. Okay, source to destination or destination to source. Next, pipes can be used only within processes that have a common ancestor. That means the 2 processes A and B both are belonging to the common parent ancestor. Say for example the parent process P here. If suppose A is belonging to some other parent and B is belonging to some other parent, we are unable to use the pipes. So just to remember, if both the processes are belonging to same ancestor, then only we are able to use the method. So this pipe is created by calling the pipe function. It is having only one argument, int file descriptor of array size 2, return 0, if okay, 1 on error. So 2 file descriptors are written through the file descriptor argument. So there is the first one is file descriptor of 0 is open for reading and file descriptor 1 is open for writing. The output of file descriptor 1 is the input for the file descriptor. What we need to understand is that just you can imagine yourself the pipe, the physical pipe only. Just we can think that there is a two ends. So one end what we can call as the reading end and the other end what we can call as the writing end here. Okay, the read end is represented by the file descriptor of 0 and write end is represented by file descriptor of 1 here. This one is we shown in the diagrammatic representation. Both the diagrams are same, but just we can make the observation there. File descriptor of 0, file descriptor of 1. So file descriptor 1 is writing the data that is connected to file descriptor of 0, nothing but it is reading the data here. In second diagram also we done the same thing. The difference is that it is passing through pipe. It is passing through pipe. The pipe is as part of the kernel here. I think you might be heard the term kernel. Okay. It is a core part of the Unix operating system. In this diagram, just we can make the observation there. If FD1 is writing the data here to the pipe, from this pipe the FD0, that is with respect to child, is reading the data here. Same thing, if child is writing the data from this end, then parent is reading the data from this end. So what we need to understand is that when we call the fork API, the child process is created. Whatever the file descriptor value is there with respect to the parents, the same thing will be inherited to the child. And next, in this diagram, the same thing what I explained here. Here, the right end is open, read end has been closed. Read end has been open and write end has been closed. That means the parent and child communicating with each other through pipe, but what we need to understand is that parent is writing the data and whereas the child is reading the data here. When one end of the pipe is closed, the following two rules are applied. That means pipe is created but one end is closed. In that case, if we read from pipe whose right end has been closed, read return 0 to indicate an end of the file. After all, the data has been read. That indicates that. So only reader processes exist. In this case, what happens? It will read the contents from the pipe until it reaches the end of the file. Whereas in the second case, if we write to a pipe whose read end has been closed, then the pipe signal will be generated. That indication that there is no reader processes exist. In that case, we need to either ignore the signal or catch it and return from the signal. And write returns 1 with error number set number. That is E pipe. That what it make it E pipe. There is no reader process, but the writer process is writing the data here. This is an example in which the parent is sending the data to the child. That means in the parent side we are closing the read end and in the child side we are closing the right end here. Just we can go through the line by line. This is the declaration part up to here, and here we are creating the pipe. If suppose it is -1, that indicate that the failure of the pipe API, then this statement is executed. If we got the other than -1, that indicate it is a successful creation of the pipe. Next, we are calling the fork API, that indicate we are creating the child process. After that, we are allowing else if PID of greater than 0, that means we are allowing the parent to execute it first rather than the child. Here, as part of the parent, here we are closing close of FD0, that is nothing but read end of the parent has been closed, nothing but the pipe. And next, the parent is writing the data hello world of length 12 to the file descriptor 1. Next else side, the side is closing the right hand, that is close FD of 1, but it is reading the contents here. Read FD 0 line. So here the line is nothing but is an array size. Max line is nothing but it is the maximum size of the array here. We are reading the data and storing number of bytes in this. Next we are calling the normal write API to write the content to the standard output file, and this is the buffer what we are having the actual data, and this is representing the size. What we need to understand is that here the parent is sending the data and child is reading the data. So what if suppose the child want to write the data and parent want to read the data, so in that case the only modification we need to do is here this condition, that is the PID is greater than 0, it should be PID is equal to 0. Here change the comment as child and here change the comment as parent. That's all. P open and P close function, these two functions handle all the dirty work that have been doing ourselves. Don't take the negative meaning with respect to the dirty work, and that means we are doing the manual work as part of the program, like creating the pipe, forking the child, closing the unused ends of the pipe, nothing but just what we done with respect to parent and child, executing a cell to run the command and waiting for the command to terminate. So these things we are doing manually. Rather than doing the manually, if I call the P open and P close function, these things will be handled automatically. That means the implementation of P open is dependent on pipe, fork, and as well as exec, whereas P close function is dependent on close as well as wait API here. Okay, so that is based on that only we are having the prototype. The termination status of command string are 1 on command string. Otherwise, we can get it as a 1 on error status with respect to these two APIs. So with respect to these two APIs, if type is R, that is nothing but second argument here, the file pointer is connected to the standard output of command string. That is nothing but here command string is nothing but the one command we are executing. Whatever the output we are getting from that, we are writing to the standard output file pointer that will read it, that is indicate R. And the second case, if we type is a W, the file pointer is connected to the standard input. That is nothing but the command string to be executed, then it is expecting the some input from the keyboard. In that case, file pointer is acting as a command pointer. So that is the reason we take the W here. Co-processes. In an Unix system, the filter concept is used. This reads the standard input and writes the standard output. Filters are normally connected linearly in shell pipeline. A filter becomes a co-process when the same program generates the filter's input and reads the filter output. A co-process normally runs in the background from a cell, and its standard input and standard output are connected to the another program using the pipe. The process creates the two pipes. One is for standard input of the co-process and one is standard output of the co-process. So what we need to understand with respect to co-process concept is that it is a kind of filter. The standard input and standard output of that filter is connected in the same program. This is the mechanism what I can call as a co-process. Okay. We'll continue in the next video.